anytime in that range. So our last speaker today is William Stein. He was a BP from 2001 to 2005. He had really quite an impact on the department. Apart from his research, he was very much involved with the graduate students, to the point that after he left, we created a position of assistant DGS, which was effectively what he was during his time. And I think Sarah Koch was also one. And also, he really undertook to work with the computers, the servers and the computers in the math department, which made a huge impact, especially for the students working in potentially computationally intensive fields. Anyway, he is going to talk about, in fact, an outgrowth of that work he did, and I'll leave it to him.
Thank you very much. So, and thanks to all the organizers of the conference and everybody for coming to this talk. And also Keith Conrad, who I think isn't here, but who proofread my slides. So, and of course found many subtle things. So here's what it's like to be a VP. This is the actual title slide from a talk I gave at Microsoft Research, kind of right in the middle of being a VP. You're surrounded by Harvard shields and mathematics everywhere, and driving around your convertible. They're all cool. At least this is like one of those things where it's how I see myself, versus how you really are. Okay, so first, I'll be talking about Sage today. I'm just curious, how many people here have ever heard of Sage besides today? Well, so that would be great. But there's some handwritten. Who's ever actually used Sage? Like actually typed something in and evaluated something? So like 2/3 of the audience, I think. And then who's actually contributed some code that's included in Sage? So 1, 2, 3. Carl Rubin, where's your hand? Your code is in Sage. Well, you have a bunch of Perry code for like doing stuff with curves of 5 torsions in Sage. So thank you. So about 5 people. So what this talk is about, it's about why and how I started the Sage project at Harvard, and what's happened since. Here's some pictures that are during Yao's 2004 birthday of Yao and Barry and Dick and grad students and so on, and that's right about when I started writing a lot of Sage code. A little background, I was an undergraduate in computer science for a couple of years before I accidentally found a math book misclassified in the computer science section of the used bookstore, and I realized that there's such a thing as groups, rings, and fields, and so I had to switch to mathematics as my major at the end. But I did get a lot of exposure to sort of normal computer science topics as an undergrad, which was great. And I'd always planned to do a lot of programming, but then I kind of stumbled upon mathematics again and really, really fell in love with it. Went to grad school at UC Berkeley. Ken Ribbett was asking a question around the department about discriminants of Hecke algebras, and I wrote some code and answered his question. That kind of got me into using software in the context of mathematical research. And as a grad student, you can sit there for years trying to have any impact at all in mathematical research and maybe not, and then suddenly something happens, and you're like, oh, that's something I can do that's helpful to the community. And software, as a grad student, was a thing that kind of got me in the door. So I wrote a lot of code in C++, and then I met David Cole, another grad student at UC Berkeley of Hendrik Lenstra, who's also my advisor. And he told me about open source software, which I'd never heard about before. And he also told me about a program called Magma, which is an incredibly powerful system for really pure mathematics. It started in group theory, but it had a lot of functionality in number theory, exact linear algebra, which means linear algebra, but where you don't have lots of floating point rounding errors. So over finite fields and over the rational numbers and so on. And Magma was like literally decades ahead of absolutely everything else at exact linear algebra and other things. Exact linear algebra turns out to be kind of really crucial input to doing calculations with modular forms, and it was one of the main bottlenecks in my software. So I started getting excited about what Magma could do, and I went down to University of Sydney in Australia, where Magma is developed, and several times, and wrote tens of thousands of lines of code that are included in Magma. It was great. I was super excited about Magma. I was able to write faster code. I really appreciated the environment. So the way it works is that there's maybe 8 or 9 people that work full-time on Magma, paid for by some license fees, and then various academics will come for maybe a month or 6 months or a year and work with them to put their code in Magma. Many, many arithmetic geometers and number theorists have gone down there and done this. But then I started to kind of realize that there were some problems with using Magma, and I have kind of a list here, but little things like each chapter of the handbook says this was written by Kevin Buzzard or something like that, and then suddenly one day all those sort of attributions to particular people disappear, and they all go in one single long list at the beginning of the book. So it's just kind of like, what if all the papers that you write, instead of being attributed to you, all the authorship goes to the beginning of the journal and it just has a bunch of papers that are due to everybody. I mean, that's, in a company, for example, that maybe makes a lot of sense because you want to get everybody to work equally, but and you want to have a single unified brand. But in academia, it starts to result in friction. And there are a lot of issues just with Magma itself. Magma, though, the amount of amazing algorithms implemented in Magma is hard to understate. It's absolutely incredible what they've done. But they started from scratch, and they wrote their own programming language, and they don't really benefit at all from the programming languages developed by computer scientists. It's very hard for them to get any funding to work on kind of core aspects of programming languages. So in some ways, they were very behind. But again, the algorithms are incredible. So that's the situation. And then coming back to open source. So in 2004, as a BP, I looked around, and that's literally a picture I took in my office on the 5th floor of the Science Center, at my laptops and at the cluster of computers that Will Hurst, as a friend of Harvard, had bought us, called MECA, an acronym that No Monkey's made up. And all the software on all of my computers was open source. You could read all the source code. It was all free, except one program, Magma. The only program out of everything that I actually cared about. The one program that was, it's a program for doing mathematics research. Not in the sense of writing proofs, but you have a matrix and you want to compute its determinant, that sort of thing. A huge amount of other things. You want to compute a space in modular forms, etc. You want to compute something about elliptic curves. So it was kind of weird to me that the only thing I actually cared about, mathematics research, was the one thing that I had to use closed source software for. And I thought maybe this was unfortunate and a little frustrating. And there can't be something intrinsic about mathematics research where it can't be that open source software gets the job done. I didn't believe that for a second. And then a little after that, in 2004, I went to an amazing conference at IHP in Paris. And Manjul gave this beautiful talk about his work on quadratic forms with John Hincke. But in it, he repeatedly mentioned ways in which he ran into kind of a brick wall with certain key things he wanted to do with quadratic forms in Magma. And if the code had been opened, he could have possibly, working with John, who did a lot of programming, they could have got past these issues. And I thought that was kind of worrisome, that the only way to really change and improve Magma is to go to Sydney, Australia, and work on the code base there. And it just seems strange to me. It's just completely different than how the rest of research mathematics works. In research math, we're super collaborative, especially in number theory, the area I know the most. If somebody else is working on the same thing as you, you don't compete with them, you write a paper with them. And it just seems strange that you kind of have so much control over something that I personally thought was going to be a big deal in the next few decades, namely computers. So what ended up happening was that John Hincke spent several years, just like a little addendum, several years writing open source quadratic forms code, which he contributed to Sage. And we have very high standards with Sage. Every single function that someone adds to Sage has to have tests that illustrate that it works, and documentation. And he somehow got some of his code in without such a thing. And so we were like, no, you have to have it. And we had a big argument. He agreed to put in the tests, and he put a lot of work into making sure his code was 100%, like everything was tested. And I don't know the details, but for some reason, he was encouraged not to stay at University of Georgia, and he ended up leaving academia. Of course, Manjul, on the other hand, didn't do a lot of programming, and he's had a beautiful career in academia. So in 2004, if you look around at mathematical software, here are the 4 main packages. Magma, which I've mentioned, which is very much aimed at pure mathematics, group theory, number theory, arithmetic geometry. Maple, which is symbolic computation. Mathematica, symbolic computation, physics, that sort of thing. And MATLAB, numerical computation. And Alan Steele, by the way, is not the founder of Magma, but he's he's an absolutely incredible coder. This is a picture I took of him when we were being tourists in Australia. I wanted to put his picture up because he's just kind of like the genius behind a huge amount of the functionality of Magma that really other things are built on top of. And he's incredibly helpful to the people that go down and visit and work on Magma. So if you go right now and you Google and ask, why is, say, Mathematica closed source? This is the page you'll find on the Mathematica website today. And here's what it says. You should realize at the outset that while knowing about the internals of Mathematica may be of intellectual interest, it is usually much less important in practice than you might at first suppose. Indeed, in almost all practical uses of Mathematica, issues about how Mathematica works inside turn out to be largely irrelevant. Particularly in more advanced applications of Mathematica, it may sometimes seem worthwhile to try to analyze internal algorithms in order to predict which way of doing a given computation will be the most efficient. But most often the analysis will not be worthwhile, for the internals of Mathematica are quite complicated. So I don't know who the target audience of that is, but if you're the sort of person who will happily spend 10 years of your life focused super hard on one research problem in mathematics, maybe you think it is worthwhile to have the option, at least, to look inside the box and to change things. And that's certainly the sort of people in the room here, and how I am, at least, with computing. And I know a lot of other people are. So I disagree with this. And then a funny thing happened, much to my surprise, in 2004. And this is the reason I started Sage, really, is that I got a job offer with tenure rather than tenure track. I went on the job market after my BP was nearly over, and I applied to lots of places. And much to my surprise, they started making me offers with tenure rather than tenure track as a competitive attempt to get me, which is an interesting thing to happen because you tell the other places you apply to that you've been given an offer with tenure, and many of them just instantly say, then we're no longer interested in you. There's no possible way we can do that because it's like a different type of search or something. But then other places become more interested. And in any case, UCSD, I accepted a position at UCSD, which is a fantastic place, which I only left because of the two-body problem. But when I went there, I then started thinking, I'm going to start a open source software package because I can spend a few years now without having to worry about my future and getting tenure. And I thought it would take a couple of years. I didn't think it would be easy. I didn't think it would take 1 year. But I started coming up with names, and then I made up the name Sage, thinking that if nothing else, it's an extremely easy word to make acronyms for. And the initial, no one could probably come up with 20 million good acronyms in a few minutes. So it started out being System for Arithmetic Geometry Experimentation. And then that's kind of constraining if you think about it. You're not going to get a lot of calculus teachers using something called that, or algebra, or possibly, anyways, we made it, first it was that, then it became System for Algebra and Geometry Experimentation, and then it just became SAGE. But then the word SAGE is maybe a little too generic, so now it's SageMath. So that's the official name of the software. Okay, so here's what I wanted. I launched Sage. I was sitting at the joint math meetings, and this guy right here with the Rubik's Cube, David Joyner, walked up to me and said, "What are you doing?" I said, "I'm trying to write a math software system." He's like, "Okay, whatever." And I decided maybe I should show it to somebody else. And I really, really wanted some open source software for research mathematics. I wanted it so that my students could use this sort of thing. And I don't know, I just thought, mathematicians should catch up with the rest of the world, or at least where the rest of the world is going. And so I put together a release, put it online, and sent him an email, and he was the first user. And then I also gave a talk on Sage. These are the first few slides of the talk. I gave this at a computer conference called PyCon, this National Python Conference. So I started out by telling them what arithmetic geometry is. They're just a bunch of programmers who probably didn't know what a group was. So it was maybe not the best presentation. And then, explain the problem, create this software. They got really obsessed with things like how could you turn handwriting into math. It wasn't really at all the sort of thing that a research mathematician worries about. And then I was a little surprised. So I made a really cool website so that students taking my Math 129 undergrad number theory course could do number theory stuff in Magma. You could type in code and see the results. And I got permission to make this site available. So it's running Magma at Harvard. You go to a web page, you type in some code, you get the answer. And John Cannon then sent me an email when he heard about Sage, and he said, "This is to formally advise you that your permission to run a general purpose calculator based on Magma expires on December 31st, 2005. This was originally set up at your request so students in your courses at Harvard could have easy access to Magma, so they don't have to install it on their own computers." Now though I contributed a lot to Magma, he owns, Magma as university does. He has every right to say that to me, and I completely respect it. But it's also a wake-up call in that, building your kind of teaching and research on top of software that somebody can just tell you not to use in a certain way, it's a choice you make, and I didn't want to do that at all. So as I mentioned, I launched Sage. A few people started hearing about it, and then this guy, this rather not very nice guy at Berkeley, who I have emailed back and forth hundreds of pages with him, I think, over the years, and I also greatly respect him. He's one of the main authors of Maxima, if you've ever heard of that. Somebody asked him what he uses recently, and a few days ago he said Maxima. So this guy has done an amazing amount of work for open source software and math software. But here's what he says about Sage. And he has a lot of experience because he's been doing this stuff since the 70s. So he says, by avoiding applications, Sage is essentially doomed. Why? Government funding for people or projects will be a small percentage of the funding for pure mathematics. That's not much, and the future is pretty grim. He's basically pointing out that he knows that the scope of funding necessary to build something like I claim to be trying to build is significant, and if I'm just getting funding from the kind of pot of money for pure math, it's probably going to be hard because it's just a little piece of the general funding for pure mathematics. But my response was, and I must have written hundreds of pages trying to argue the opposite, and now I'm not so sure. Here's a picture from the first Sage days. So I went to UC San Diego and discovered that NSF money used for conferences doesn't have overhead expenses added on, and shuffled some grants around and waited about 4 months to get official permission from the NSF. And then I threw a conference, and lots of people came. And it was the first Sage Days conference, and we had leaders of various open source projects like GAP and IPython and so on give talks, and other people gave talks. We had lots of coding sprints, and this is the first one, but it's been a very successful conference series. We've had over 80 conferences since then. So just this year I looked, and there'll be future conferences in Vancouver, Hawaii, France, and Israel just during 2016. Some years we've had up to 13 or 14 of these workshops. So in a sense, Sage is kind of like this virtual institute where there are conferences all over the world, but about open source software. So the project's launched, I started having conferences, and then the surprise to me is instead of getting extreme criticism like I got from Fateman, at the conference there's lots and lots of enthusiastic support, and people hope that Sage will turn from this bug-ridden mess into something that they can really use in their work and be really useful. And so other people start working on the project, and so there's always people, popping up saying, I want to do this or I want to do that. And in order to clarify what makes sense to do in Sage and what doesn't, we came up with a mission statement, or I came up with a mission statement, which was create a viable, free, open source alternative to Magma, Maple, Mathematica, and MATLAB. What this means is different for different people. For me personally, it means that the sort of calculations with modular forms and elliptic curves that I want to do are possible in Sage. But for other people, for example, people teaching lots of calculus, it means that certain functionality that Mathematica provides, for example, is available in Sage. And this is a nice inclusive mission statement. It also, I think, very much clarified our relationship to other open source projects. And my impression was that before Sage, a lot of open source math projects would compete with each other. So you'd have Singular and Macaulay, for example, and they're both commutative algebra systems, or you have Cache and Gap, and they're both group theory systems that are open in some ways. And this mission statement, this goal, isn't to be better than other open source projects. It's not to publish papers. It's not to solve some big challenge problem. So it's a horrible goal as far as getting grants goes, as it turns out. But it's a really good goal for clarifying that you just want all the open source projects to work together. And that anything that improves any open source software out there that you can then indirectly leverage in Sage is great. So by the way, what's the architecture of Sage? You take Python, which is a very standard mainstream programming language, and then you take the best of a large number of open source libraries and make them work well with Python. And then you go, oh wait, there's no algorithm for doing blah anywhere in the open source world. And there's lots of situations like this. And then you implement that algorithm. That's it. That's how Sage is built. And yeah. So that's our goal. Our goal is to improve the entire open source ecosystem for mathematics and to give you and your students more options. So then I moved to University of Washington entirely because of the two-body problem. So it's a fantastic department. And I built a team of students there. And these are just some of the many students that worked on Sage. Pretty quickly after I got there, I found a bunch of amazing people, absolutely incredible programmers. Several of those people now work at Google, for example, as senior software engineers, and have had a big impact there. But then I started to find that there was kind of a flaw in my master plan. Of course, these things have been pointed out to me repeatedly, though usually Feitman would claim that kind of math undergrads or grad students couldn't possibly program at all, but he was very wrong about that. But there were other flaws that he hadn't pointed out. But one was that everybody graduated and I couldn't hire anyone. Every single student, they would work for years. They would get amazingly good at writing math software. They would know Sage inside and out. They would rewrite key parts of the architecture, and then they would go work at Google and never touch Sage again. And it was just terrifying. It was terrible because it just happened over and over and over again. And if I had the money, they would have continued to work on Sage. They would have much preferred to do that, but I didn't at all have the money to even begin to compete with that. I couldn't even hire them full-time as postdocs without teaching. It would be full-time with several classes of teaching. So that didn't work so well. And this happened. There's also there may have been a misinterpretation that I had tons of grants funding Sage, but I didn't. I had grants funding number theory research, which I kind of would divert to Sage days. So I kind of just, somewhat hacked the system to get some funding to get Sage going in the hopes that later then I could apply for grants for Sage. And people would assume I have tons of grants, so they'd go work on Sage, and then they'd knock on my door and be like, can you please hire me all summer to work on Sage and rewrite this amazing thing I have? And I'd be like, I wish I could, but I can't. So it happened kind of repeatedly. And actually, I never once got the funding to hire one person full-time to work on Sage. Finally, this year in Europe, there's this Open Dreamkit grant, which the EU is funding. It's like $8 million for open source software across Europe. And there are 2 people working full-time on Sage funded by that grant. So it seems that Europe is dramatically better at funding work on open source software than the United States. On the other hand, the 3 of the 4 commercial math software systems are American that I mentioned. So I guess we're really good at companies. Okay, how am I doing on time? So here's something called, just to give you a sense, I mean, when you look at open source software, there's a lot of examples outside of mathematics. Mathematics isn't really necessarily that special at all. There was something called Heartbleed a couple of years ago, in which a massive bug in OpenSSL, this does basically an implementation of Diffie-Hellman and some other algorithms, but it's used by, like anything using Linux is using it. So hundreds of thousands of companies, billion-dollar companies are, probably almost every company is using OpenSSL. And here's the situation with the OpenSSL developers. I'll just read this quote. There should be at least a half dozen full-time OpenSSL team members, not just one, able to concentrate on the care and feeding of OpenSSL without having to hustle commercial work. If you're a corporate or government decision maker in a position to do something about it, give it some thought. Please, I'm getting old and weary. So this is from one of the core developers of OpenSSL, which is a very, very heavily used open source project. This bug was huge, by the way. I mean, it made it so that hundreds of thousands of websites for a little while, for a couple of years actually, if somebody had exploited the bug, people could get people's logins and passwords off of them. They were very, very hackable. It was really bad. The bug was only found when some guy at Google just sat down and started auditing the code of OpenSSL and just ran into the bug. And funding for OpenSSL apparently got a lot better as a result of the publicity from their failure. Okay. So a really exciting thing happened in 2012. I got an email from David Eisenbud, and he invited me to a meeting at the Simons Foundation headquarters in New York City. And the goal is the following. The purpose of this roundtable is to investigate what sorts of support would facilitate the development, deployment, and maintenance of open source software used for fundamental research in mathematics. And he talks about physics and some other areas. The scale of foundation support could be substantial, perhaps up to several $1 million per year. So I was like, wow, finally. These guys are serious. They really understand what's going on. There's hope. This is the moment I've been spending years preparing. Like, had all these stage days, done all the foundational work, hacked the NSF grants, did what I had to do. We're ready to go. So I went to the roundtable discussion, and the decision that was made was to fund Magma for all North American academic institutes. I mean, it's just what happened. And it wasn't a result of the people at the roundtable deciding to do this. The people were a bunch of great open source advocates and people involved in various other open source projects, like Susan Holmes from Stanford and the R project and so on. We had lots of, I think, great discussions and ideas, but then the real decision, which had nothing to do with our discussions, was this. And this was, in fairness, David explained to me that this was what they had really decided. And I explained to him that, I know, because people come to me and tell me all the time why they use Sage or contribute. In fact, you, right in the middle, you came to me 2 days ago and said, I use Sage specifically because I couldn't afford to use, where are you from? From Chile. But he was in Canada. So he was in Canada and he used Sage and used it a lot for elliptic curve computations because he couldn't get Magma. He didn't want to have to buy it, it's $1,000, whatever. And this was an absolutely massive motivator for people to contribute to Sage and to use Sage. Maybe the main one for the people in number theory and arithmetic geometry type areas. And suddenly, it was just made free to all of North America. And that's the one thing they did. So it didn't really help in the same way that I had hoped it would. So when I mention issues with funding, people often tell me things like the following. This is an exact quote from somebody. Jim Simons is a true academic at heart. Approach his fund. I'm 100% sure he'll give you a grant on the spot. So I got enough of people telling me that I wrote in 2015 to the Simons Foundation and just got an email back that kind of reiterated what had happened in 2012. And so, again, I'm not saying there's anything wrong with this. It's their money. They can do whatever they want with it. But it's unfortunate, that's all. So as a direct result of that experience, and in a kind of meta sense also, knowing that even if they had said, sure, let's do it, what if the next year they say, no, actually, let's not do it? Like, there's so much, when you are completely funding your life stream based on, one foundation saying, here's a check, that's dangerous. So maybe they did a big favor by saying no, I don't know. But I started writing something called SageMath Cloud pretty soon after that meeting because I thought, well, it'd be good if we, actually tried to do something that people would value so much that they would pay for it, and then we can make some money in a more sustainable way. I know sustainable is like an annoying buzzword, but it's good to diversify. And so SageMath Cloud, by the way, it's much more than just Sage. It's a web page where you can use Sage interactively and a lot of other open source software like R, Octave, Julia, et cetera, down. But everything that's open source and related to math is available there, absolutely everything. There's a sophisticated course management system that's part of SageMath Cloud. There's a collaborative LaTeX editor. Absolutely everything in SageMath Cloud is collaborative, so it's like Google Docs in that you can have multiple people editing things at the same time. And there's also terminals. It's a Linux environment behind the scenes. So it's something where academics can collaborate together on research papers, people teaching courses can use it, and it'll save them a lot of time and greatly reduce the friction to using Sage and other open source software. You don't have to install anything. So I started working on that 4 years ago, and right now it's starting to get pretty mature and polished. I'll say more about that later. So it's now even more than 10 years since I launched Sage. So how about a status report? This is the Google Analytics monthly active users plot from 2008 through now, through yesterday. So what this is it's a measure of the number of people who go to the Sage website more than once. So they're active users. So the number of actual users of Sage, whatever that is some function of this graph. Okay, it's something we know for sure that we can, say that gives us some indication of how many people use Sage. And it turns out it went up from 2008 through 2011 to about 50,000, just over 50,000. It has been completely stable, modulo seasonal fluctuation, from 2011 until now. There's been no growth at all. And it's at about 50,000. And that's a lot less than just Mathematica, at least. Like you can get pretty good estimates about the usage of other websites like Mathematica and Maple, and they're all on the order of 20 to 100 times more. So Sage is definitely a niche product overall compared to those products. And I also run a booth. If you ever go to the joint math meetings, come by and say hi and get a sticker and stuff on Sage. And I sit there all day, or I stand there actually often all day long talking to people, often college teachers, and a huge number of them come up and tell me why they're using Mathematica instead of Sage. And so I know that Mathematica is clearly doing something that Sage isn't doing, and that Sage somehow hasn't fully, provided a viable alternative to the MAs, which is our goal. Yes?
So why are they using Mathematica instead of Sage?
Lots of reasons. For example, it's maybe difficult to install Sage. Maybe the documentation of Sage is difficult to read. Maybe there's a key piece of functionality in Mathematica that they use that Sage doesn't have. So it'll be a range of reasons. Or maybe they just don't know that Sage does everything they need. Like often they'll be like, can Sage do anything with 3D graphics? And the answer is yes, we do a huge amount with 3D graphics since 2008, but they don't know that. But, yep. So it's not just that Sage, maybe you might imagine Sage is great at, arithmetic geometry and number theory, and it does everything I need, but that's actually not at all the case, which is really frustrating. But here's an email from David Cole this morning in which he says Sage is not on par with Magma in arithmetic geometry. And I really know at a low level what he means. There's a lot of functionality for working with quaternion algebras, which is very relevant to computing with Hilbert modular forms. And Sage is just dramatically way behind what Magma has. And there are many, many other things like that, where it's really core research-related functionality that I and you should care a lot about, that the only way that you could do it is using Magma or closed source software. So after 10 years, Sage isn't there yet. And it's very hard to get it to be there. But there are, I mean, there's not some intrinsic reason why Sage, being open source, isn't going to potentially provide a viable alternative to the other software. Here's an example of the market share of web browsers. That blue line, which is going down a lot, is a web browser that was very popular, totally dominated the market a few years ago, Internet Explorer. And it no longer, I mean, I'm sad for my friends in Seattle, but it no longer is the dominant operating system. And the green line that's going up very quickly is Google Chrome, which is almost entirely open source. There's a few like closed source add-ons for Flash probably, but it's a 99.99% open source web browser, which Google has made and funded the development of. And they did it because they wanted people to browse the web more. And they wanted, and it actually dramatically changed the whole situation with the web. When Chrome was introduced, it was just way faster than everything else, and it completely changed the landscape. So they innovated purely not to make money off of selling Chrome, but to make the web better. Another example where open source has done very well is R, a statistics program. This was a recent survey from a few days ago in which somebody looked at all the scholarly articles in the last year and what software they used, and R is now ahead of SAS, which is the main commercial statistics software. And I think SPSS is kind of different and more like social sciences button clicky thing. But R is the dominant program in sort of serious statistical computation. And SAS, look at the bottom. It has percentage change in the number of articles for SAS from 1 year to the next. And it's down 25%. So the commercial statistics program software is going down. The open source software like R is dramatically improving in terms of market share. And I mean, R is really fantastic. R, by the way, also has very strong commercial backing. There was a company called Revolution Analytics. I met with a bunch of their employees like in 2007 and realized how outclassed we were in terms of resources at the time. But they're now owned by Microsoft. So Microsoft is one of the main commercial players pushing R right now, in case you didn't know that. I think I worked in, let me read a quote going back. So, I mean, I've tried in various ways to fund work on Sage, and I think I've really failed. I mean, one thing I don't mention in here is that I tried really applying for grants for Sage, like really for Sage to NSF, instead of other things, and then using the money on Sage. And I've got a whole bunch of grants denied in a row. So I don't know how to get Sage funded via grants. A friend of mine, Fernando Peirce at Berkeley, has got some significant grants for Python-related things, but it's an absolutely massive amount of work. And again, you're depending very much on these granting organizations. So maybe I'm just very bad at it, but I can't fund Sage that way. So I looked back at this really, really old interview with Stephen Wolfram, who, like him or not, he may actually be an incredibly smart guy in certain ways and know what he's talking about. So here's what he has to say about creating mathematical software. The mathematical community sort of hate one aspect of what I've done, which is to take intellectual developments and make a company out of them and sell things to people. My own view of that, which has hardened over the years, is, my God, that's the right thing to do. If you look at what's happened with tech, for example, which went in the other direction, well, Mathematica could not have been brought to where it is today if it had not been done as a commercial effort. The amount of money that has to be spent to do all the details of a development, you just can't support that in any other way than this unique American idea of the entrepreneurial company. So I literally read this quote at talks 8 or 9 years ago and talked about how I was absolutely certain he was completely wrong and that I would prove him wrong. Now I'm not so sure. Maybe he's right. So very recently I got an email from somebody. Dear Professor Stein, I'm a relatively new assistant professor in math with a heavy software bent, and I can't help but note your recent frustration about academic respect for software libraries. To put it mildly, I find this concerning, as my software output is by far my biggest effort and output. If you were a new faculty member again, would you start something like SageMath Cloud sooner or simply leave for industry? And, it's a dangerous question to get. If you could go back in time 10 years, what would you do? And I actually, honestly, when I thought about that question, we had thought about starting a company about 9 or 10 years ago, and I would be probably way better off now if I had done that as far as the project goes. Sage would probably be way better off. If I had done the work to build up a company, I would have this thing that generates revenue, funds development, etc. So that's what I think. I clearly must think that. So I wrote back and explained that. And then he wrote back to me and he said, I'm sitting on an offer from Google and I'm increasingly frustrated. He feels like, this is not me writing, this is him, deep mathematical software is not appreciated by either the mathematicians or the public. It's not surprising the general public doesn't appreciate deep math software. But there are a lot of people that write really deep mathematical software and they feel that it's not appreciated by their colleagues, that they're viewed as sort of these weird creatures that make math software, but it's not the same thing, the same quality as real mathematics. He said, I've been on the fence about accepting the offer, and this conversation led me to make the difficult decision. So now he works at Google now. And that's Jack Paulson from Stanford. And then another person wrote to me yesterday, and he just kind of said, here, let me summarize the situation for software dev in academia. This person's in computer science, not mathematics. So they use terms like hard money and soft money, which we don't use so much. Hard money for software development is virtually non-existent. I can't think of anyone I know who got tenured based on his or her software. Researchers on soft money are systematically discriminated against in favor of tenure track and tenured faculty. And researchers are increasingly evaluated solely on the number of publications. And Fernando Perez, who I mentioned before, the founder of the IPython project, Jupyter Notebooks, etc., at Berkeley, he says, this hits particularly home. I am sort of the walking example of this painful trifecta. And so he doesn't know, I mean, he's sort of, well, he didn't write that, but he experiences it. Here's another example. Here's a quote, nobody quite knows who said it, but it seems to be true. Every great open source math library is built on the ashes of someone's academic career. And here's a great example of that. Travis Oliphant, he was it just says professor here, but he was a tenure track assistant professor at Brigham Young University. And he wrote SciPy and also NumPy. These are in data, have you ever heard of data science? These are the canonical basic libraries that everything else builds on in the entire Python ecosystem. Take any number that measure the popularity of Sage. These are 10 to 100 times more important and popular in the sciences. These are not just like random libraries that might be kind of amazing, but they are really foundational. And right as he's coming up for tenure, he's winning an award for being like for contributing the most to scientific Python. I remember being at this ceremony. So they denied him tenure. I was one of the people that wrote explaining how important all of his work was in software, but Brigham Young just flatly denied him tenure. And it wasn't he just happily left. He didn't want to leave academia. But he's had a great career since in industry. He worked at Enthought, a Python consulting company, and he's now the CEO of Continuum Analytics, which is a big open source software type consulting company. Okay, this is my last slide, and here's the conclusion. I'm leaving academia to build a company. I'm not leaving mathematics at all. The company has the word math right in its name, but I don't think that academia is the most optimal place for me to get what I need to get done. And more importantly, I want to say that my department and academia have been very good to me personally. It's all the other people that I feel I can support much better by building a company. And maybe an institute could have worked, but I missed the boat on that, and I don't know how to do it. So I'm trying a company. And if it works, it will be sustainable, I think. So we did launch a company about a year ago, but I'm going to start working full time on it, and as soon as the Rubin Fest is over. So there you are. So that's everything I wanted to show you, and there's certainly a few minutes left if you'd like to ask any questions or make any comments. Okay, thank you. Yes? So his question is, what was my comparison with tech about? And this was not me, this was Stephen Wolfram. And this is 1993. So I think Stephen turned out to be wrong. I think tech has been a fantastic success. One of the many reasons is that there have been a number of companies that have, provided like tech environments, made money, and like share a lot. There are companies that make tech easily available online, and they improve tech, and just lots of people improve tech. There's a Tech Foundation or something. The AMS, the American Math Society, has put absolutely tremendous effort into making tech awesome. So I think that Stephen Wolfram's completely wrong about tech. I think tech has really turned out very nicely. I went to a conference once, and the two plenary speakers were me and Stephen Wolfram, and so it was fun. Sage has really, really good support all over the place for using tech, and Mathematica less so. And he was really dismissive of tech, and he got boos from the audience. Because mathematicians like tech, I mean, let's face it. It's a beautiful, beautiful system. So yeah, that's the answer to your question. Daniel, sorry.
I remember Kevin Buzzard telling me a story of correspondence back and forth between him and the mathematical folks about a crime, which Mathematica said was a crime, but actually wasn't.
Okay.
And he says, sort of back and forth, he said, show me the crime, he said, show me the code. So one of my worries about closed source software isn't just the corporateness of it and permissions required, but the fact that it's impossible, in principle, to tell if the calculation was done correctly.
Yeah,
Say anything about that.
So that used to be kind of like one of the main themes when I would try to convince people Sage is worth using, which is that open source, when something goes wrong with a calculation, you can look at why and maybe fix it, and you can also understand what's going on. I don't know the specific story you asked about with Kevin, though I know that Magma had a bug in the nth prime function, which was pretty bad, where for some value of n, it gave a composite number. There's also a recent a recent notices article, which was about a bug in the determinant function in Mathematica. And some Sage developers, including me, wrote a follow-up article about how a similar bug in the determinant function of Sage got fixed. And we explained how it was very much a community project. Point to the website where you can see every single thing that happened, how the peer review works for comparison. Whereas with the Mathematica bug, the authors just write back and forth to Mathematica, and it's more of a black box experience. So there's definitely a lot of advantages. If we put in the effort to make open source software that we can really use for our research, there are lots of advantages for mathematics research. In the same way that by actually proving theorems instead of just making conjectures and playing around with divergence theories and pretending things work, we can actually make mathematics better. So your hand is up next.
Two questions. Will it remain free and will it remain open source?
His questions are, will Sage remain free and will Sage remain open source? And the answers are absolutely yes. The copyright of Sage and the license is the GPL, the GNU Public License. It's spread across the over 500 people who have contributed to Sage over the years. So there's no possible way to close source Sage. Sage also derives from other programs that are GPL licensed, and that license requires derived works to have the same license. So it's just completely impossible for Sage to ever be closed source. Regarding free versus not free, Sage itself is completely free. SageMath Cloud, the website I mentioned, the source code of it is completely free. You can run it yourself. However, if you want to use it, we have an option to pay to get faster or better resources because we're paying for the hosting. Okay, Cameron.
So do you expect or hope that SageMath Inc. will mostly make money from things like SageMath Cloud, like you just mentioned, or consulting like Human Analytics?
So his question is, what is the business model of SageMath Cloud? And the hope is that SageMath Cloud will make money from people paying to use SageMath, or SageMath Inc. will make money not from consulting, but from people using SageMath Cloud for teaching and research purposes. So that's the business model. Right now, we are losing a lot of money every month, but we have a generous investor who is making it so that hopefully we can turn that around in a year. We make more money than we spend on hosting, at least, but we lose money on people. Yes?
All the questions have already been asked.
Oh, please.
Well, I
Okay, got it. Behind you. There's a person right behind you. Much to your service. I really wish. We have extremely limited money still. So we have we have a couple of people who have invested a small amount. And if we do well, then we will hire more people. My plan is to build a company with about 30 people total if things work out. And we'll be distributed, so it'll be all remote work, no central office. And some of those people will contribute to the core of Sage. That'll be their main job. Other people will work on the website and that sort of thing. And the overall mission of the company is just to make open source math software overall way better, because then that makes the website way better and more accessible. Yeah, sorry. But yeah, we need to make more money before we can hire more people than we've already hired. So I'm very nervous when I look at how much I have to pay people next month. So starting a company is stressful, as it turns out. But please email me. Please do email me, though. Okay? Any other? Oh, yes?
What if you raise VC, exit, that exit means that Magma...
Wait. Your question started with the words VC, I think?
VC.
Okay, so let me stop you right there. So there is his question was, when we exit, because we got VC, so VC stands for Venture Capital Funding. SageMath Inc. does not have any venture capital funding. The investors are angel investors only, and we don't plan to ever have any venture capital funding.
You're willing to accept VC?
No. We will only have investors that are angel investors and who have a passionate love of mathematics. I won't name any names, but one of those people is in this room. Okay? So I've worried a lot about that, and I'd love to talk to you afterwards, because clearly you know something about this world that is pretty dangerous. Any other questions or comments? Okay, thank you.
Listen, the first year I found it, just keep your blood pressure down. You have a really good product. People are going to catch on to it. There are more angels in the world.
There are more angels in the world. That's right.
So, by the
Yes.
way, my name is Hiro. I'm one of the chemicals.
One of the ones. Okay, cool.
So, I have this. It has a lot of money, and I think it would be really interesting to this kind of thing.
I would obviously be interested in talking to them.
So, do you know the person who started Duolingo?
What is it?
Duolingo?
Duolingo. I don't know.
It's a crowdsourced language learning thing.
Uh-huh.
Do you know the person who started
I'll see you later. All right.
the thing that you have to click to verify you're a human?
Yep. Oh, let me turn off this screencast.